can do 2 clicks in the screen, so the screen will be bigger to you see our class, okay?
Okay.
2 clicks in the screen. So, okay, let's go. Consider the matrix, compute the product. Okay, product of matrix is easy, but is very you need to do a lot of math, a lot of calculations, but it's easy calculations like times and like sums. Okay, you only need to know the algorithm of the situation, right? So I
Yeah.
will show to you. Let's go. We want the product A times B. In matrices, the order of the terms import. So A times B is different of B times A, okay? This
Okay.
is the first thing you need to know. Okay, so you know that. Another important thing you need to know. When we do times multiplication with matrices, you need the matrix have um, um, a specific number of lines and
Mhm.
rows. Okay, for example,
Okay.
this matrix have 2 lines and 2 rows. These 2. Okay,
Yeah.
so we can do this math, this calculation, because these 2 numbers is equal. These 2 numbers need to be equal to do this calculation. And your answer will have 2 lines and 2 rows. Okay?
Okay.
So these numbers need to be equal, and these numbers will be the size of your matrix. Okay, let's go. I will write the matrix here. 2 minus 3, 4 minus 6, and here we have 9 minus 6, 6 minus 4. So uh, first, we need take this number and multiply of this number. We put this answer here, 80, plus the multiplication of this number and this number. First line, first row. Okay?
Okay.
First line, first row. Now we have first line, second row to take the first line, second row term of the answer. Okay. You can see the symmetry of the colors. This is very interesting to understand the subject here in the moment. Okay, so
Okay.
let's go to the final part of this matrix. We have 4 times 9. This is 36, and minus 6 times positive 6. So 36 again. And we have for the last time minus 24 plus 24. So this matrix have a interesting result, 0, 0, 0, 0. This is a null matrix, okay?
Okay.
But you can see it's very easy. It's just do times and sum, multiplications and sums. Very easy,
Okay.
okay?
Yeah.
I suppose you can do something now. In my class, I ever ask to my students do some calculation in the class. Okay, so I will ask to you do multiplication. Right? Let's
Okay.
go. Our first matrix is 1, 2, 3, 4, and the another matrix is 5, 6, 7, 8. Okay, so
Yeah.
you need to do for us A times B.
Okay.
Okay, so I will show to you my example. You can see the example to do the same thing in your calculation, right? When
Yeah.
you finish your calculation, you can send me a photo, right?
Sorry,
A
I could not
photo.
hear you.
You can send me a photograph of your calculation, right?
Okay. Yeah.
Okay. Okay. Uh, take your time to do this. I am very calm and patient. Okay.
Okay.
So let's go. Will you have a test?
Yes.
When will be the test?
1 second. The test will be on. Let me just check on my calendar because I know the exam of this subject is on 27th May.
Mhm.
And let me just check when will be the test.
Let me see if you are right or not. First term, first line, first row. First line, first row. So you don't pay attention in the symmetry of colors, right? Because you just, I don't know, you just do the multiplication of the first term with the line of the another matrix, but not this which I do. I did. I did. You can see um, red one, red one, red one, red one. Okay. So
Okay.
first line, first row. You you don't do that. Okay. You did not that. Just a second. Here, you can see first term, first line, first term, first row. Right. Okay.
Okay.
Second term, first line. Second term, first row.
Okay.
And you didn't do that, right? So
Yeah.
you need to do again. But I will do this now. Okay. So I will ask you another matrix, right? I will do here. Just a
Okay.
second. I will do for you. No problem. Oh, again, we have, sorry, right? Okay. So first term of the first line, first term of the first row, red one. Okay. Second term, second term. Again, first thing, second row, first line, second row. Oh, sorry, 12 plus 2 times 8, 16.
Okay.
3 times 5, 50. 4 times 7, 28. Then finish 3, 6, 18. 4, 8, 32. So do you understand? We have a symmetry of colors here. Do you remember? Do you look at possible errors? Okay. So
Okay.
here is right again. Perfect. I will ask to you, please do this for me. Let me see. I will put the inverse. The inverse.
I
I
have a
do.
question.
Okay, please.
When you multiply the 3, it will be 3 times 5 and 3 times 7, right?
No. 3 times 5, 4 times 7. 4 times 7, right? You can see the blue arrow, the blue ring in 4, okay? And the blue ring in 7 too, right?
Okay.
So the first, the terms of the line to multiply to the terms of the row, okay? The two
Okay.
terms of the line, the two terms of the row, right?
Okay.
Okay, so you can try again, but at this time, B times A, okay? The inverse.
Okay.
Okay. Take your time.
Okay. I'm not understanding it. I'm making a mistake again.
Oh, but you can send me the photo to me understand your error,
Because I'm
right?
not understanding the calculation of the A times B. Like when you did 1 times 5, but you also did 1 times 7 in the first row.
Ah, okay. Yeah, I am wrong in this situation. Sorry. The error is mine. Okay, so
Okay.
1 times 5, right? 2
Mm-hmm.
times 7, 2 times 7. I am wrong. Here is 14, right? Here
Okay.
I am right. You know. Oh
Yes.
my God, I am um, I am wrong now. Sorry.
Okay.
6. Sorry. And here I am right. 3 times 5, 4 times 7, and the last one, 18, 32. Sorry, I am right in that situation.
Okay.
The another questions is a little hard because involves some advanced theory. Okay, for example, in Brazil, this problem we are doing now is a high school problem, right? So
Yeah.
this problem here, for example, this is a advanced problem, but only the theory, the math is the same. It's the same thing. It is
Okay.
so hard than this. Okay, but I suppose you understand the logic of the multiplication of matrix. Okay,
Yes.
it's just the detail in your situation, the problem. But okay, let's go
Okay.
to the B. Sorry,
I'm just sending you the picture.
you send me.
Yeah.
Okay, let me see. Let me see. Um, just a second. I am open here. Okay, B times A, 1. Okay, let me see. 5 times 1, 6 times 3. Right, the first one. Right. 5 times 1. I suppose you change the order, the things. But okay. You this is right, this is wrong. Okay. But I
Okay.
will do again. So
Okay.
I will write again to be more didactic. This is the B. This is the matrix A. So let's go put the rings. The rings is very helpful. 5, 1, 5, 6, 3, right? 6 times 3, 18. Okay, let's go to the another one. 5 times 2, 10. 6 times 4, 24. Okay,
Okay.
let's close the matrix. Second line. 7 times 1, 7. 8 times 3, 24. And the last one, 7 times 2, 14. And 80 times 4, 32. You can see all the numbers have the same quantity of rings. Okay, two
Okay.
rings, the same color, the same symmetry of colors, and here
Okay.
two rings. So if you use this in your uh, first steps, will be more interesting to you, right? Okay,
Yeah.
let's go to the another question. Question B: determine the consistency of the system. We have an answer here: inconsistent system. Uh, did you do this calculation?
No.
No.
This is a source
This
paper.
answer, this answer is not yours.
No.
Okay, perfect. So let's understand what happened here. This is an equation, right? This is an equation. So we have the multiplication of the two matrix times a line equation of variables. Okay,
Okay.
when we see x in this situation, this is a line or a row what have x, y, and z incognitas variables to to solve some equation. In this situation, this equation here, we have a line 0 and 6, but we have this letter here, t is transposed. Transposed, you need to change the lines for rows, right? So another form
Yeah.
to write this is this one, okay? We change, this
Okay.
is a line, but this transform in a row, okay?
Okay.
Because the letter T. Okay, so we have this multiplication too. We have A times B. I do this for you, but I don't do the sums, and you correcting me. So we have 19, 22, 15 plus 28, uh, 40, 43. And here we have 15, right? This is the multiplication, so I will use this here because we have this multiplication here, right?
Yeah.
So uh, we need to think a little bit here. Why? Because we have this matrix, we need to put something here. I will put this X for that moment. And we have this matrix here. So we need to understand what is this? What type of matrix is this? Okay, so we need to know the rules of the size of the matrix I said to you, right? For example,
Yeah.
here we have two lines and one row, right? Here we have two lines and two rows. I say to you is necessary. We have a specific size here. This matrix needs to be a specific size first to have the multiplication.
Yeah.
We have two here because these numbers need to be equal. Do you remember?
Yes.
Did you?
Yeah.
Okay, perfect. So I have the number 1 here because this I need to be 1 here too. So this is the size of the matrix. X is a matrix 2 times 1, 2 lines, 1 row. Okay?
Okay.
So I said to you, X is a matrix of variables. So I need put here 2 variables, for example, X and Y. And now
Okay.
we need to solve a system of equations. A system of equations is a thing we did learn in school, in high school or middle school. Is a easy math, okay? But you
Okay.
need to remember. I am sure you studied this in your high school or middle school, but we need to remember, not problem, right?
Yeah.
What we need to do? We need to transform this matrix equation in a functional equation, in a algebraic equation. Okay, to
Okay.
understand better, we need to do. So again, we need to do some multiplications to transform this in a algebraic equation, right? So let's go.
Yes.
We need to multiply this for this and this for this. So let's go. 19x plus 22y equals 0, because it's the first term of our answer. Okay? Again, second line, first term. Second line, first term. The answer will be 6. You can see again the symmetry of colors, the number of rings, to pay attention about some errors. Okay, so we have these two equations. We can solve this problem now. We have a lot of the ways to solve this system. Okay, but first you need to understand. We need get a value of x and a value of y to solve these two systems at the same time with the same x and y values. Okay, so have one value of x and one value of y to solve this system at the same time. We need to. We can do the next step. We can isolate x in the first equation, for example. We need isolate x. If we isolate x, we will be 22y minus, because we need transfer the number to another side, right?
Yes.
So we change the sign, yeah. Okay.
Yes.
So 19 is multiply the x. If multiply goes to another side, divided over 19, right? Okay.
Yes.
I isolate the number. Isolate the number here, but I take the right situation. Oh my God, I don't take the right situation. Sorry, I take my A and my B, but your A and your B is 0, 0, 0, 0. Okay, but okay. I will finish this problem, right? But this is not the problem of your test, right? But it's important to me explain this for you because this is a common situation in metrics, right? But your matrix is different. Your matrix is 0, 0, the new matrix, right? But I will finish this problem because it's important. So after I will explain to you using the new matrix, right? So let's finish this. Okay, we can copy and we can change x for this number. Oh, okay. So we have only an equation with one letter, one variable, y. Okay, the letter y. So and now we can isolate y and we get the value of y, right? I don't know. I will not do the math, but you can do this after our class just to train, right? Because this is very important in the matrix math. So when you have the y value, you can put this value here to obtain the x value, right?
Yes.
Okay, so it's very easy. Here is just easy math like sum and subtract. Okay, isolate the number. I will not do this because we need a lot of other things to do, right? But let's talk about the real A times B matrix. Is this? So let's give it real. Okay, so x, y, we already talked about this, and we have here 0 and 6. So we have how can I say, inconsistent system, because if we do the same math again, 0 times x is 0, right?
Yes.
0 times y, 2. equals 0. Perfect. Here is okay, because 0 equals 0. This is a normal thing. But here is not normal, because we have 0 plus 0 times y. 0, 2.
Yes.
What is the answer? 6. 0 is
Six.
not equal 6. So this is an error, okay? Because this we
Yeah.
have a inconsistent system. So we have
Okay.
a lot of types of system. We have inconsistent system. We have this system here is a normal system when we have one value to y and one value to x, but we have a third type of system is the infinite system. So we have infinite answers to x and y. Okay. Another time I show it to you, right? Okay.
Yeah.
So we have, do you understand? I can continue. Can I continue?
Yes.
Okay. Thanks. Let's go. Let's go to the another one. This question, we have the answer here. Y different of 0, but okay. Let me see. So we have 3 row matrix, and they ask, indicate all values of A for each the vectors v1 at and h are linearly independent. Okay. We need to understand what is linearly independent. Linear independent is when you cannot obtain a matrix multiplying another matrix for a number, right?
Yeah.
Linearly independent is when you cannot obtain a matrix, multiply another matrix for a number. For example, we have here the V1, 4, 0, 0. To don't be linearly independent, we need to be different to a constant that's multiply 5, 0, and y. Okay? So the problem is, if we write this system again, like the another question, we have, for example, 4 equals k times 5, 0, sorry, another colors, 0 equals 0 or different. This is just a interpretation here. I will speak about this. And here again, 0 equals, let me see, k times y. So if you see this, we can understand a thing. If we have y equals 0, it's possible to us obtain this vector, how a multiply of this. Okay? If y is 0. Do you understand? If I put 0 here, I need just control the value of k to obtain this vector, right?
Yes.
If the y is 0. But if y is not 0, it's impossible you control the k to this multiplication here, obtain this. Okay?
Okay.
So we just obtain this result, understand the theory about linear independence, and see and watch, observe the numbers. We don't have a specific math to do. Do you understand? This is a very theoric. Okay.
Okay.
Okay. So I see this math. I observe. I cannot take y equals 0 because if y equals 0, k can be a number to transform this and this, and the number is very easy to obtain too. 4/5. So we need to explain this in words. Okay, I will explain this in words to you. Remember, if y is 0, the vector h can be equal v1 controlling the value of k. Okay.
Okay.
Okay. Any doubt?
No.
No. Oh, very amazing. Let's go to the another one too. Suppose y equals 2. Okay, it's not linearly independent. Compute a and b such we have this equation here. Okay, so again, we need to solve an equation, a system of equations, right? Similar to the matrix 1. Okay, the matrix we did here, right? We need to do a system like that in this question here. Okay, so let's go. A times V1. A times V1. V1 is this matrix. I prefer write this in horizontal because it's more easy to work. Okay, horizontal is more easy, more beautiful too. Okay, V2 is this 306. And finally, we want this sum using these coefficients. So we need to control, we need to find these coefficients, right? To this multiplication, obtain 5, 0 and y. 5, 0 and 2. Okay? Okay, so I don't have more space in this file. I will open another one. Just
Okay.
a second. Just a second. Okay. I will open another one. Okay, it's here. So again, we need to multiply the things, right? And sum the right things. Because you need to understand the vectors is objects, real objects, real three-dimensional objects. This first position is the x position. The second is the y position. X, y, z coordinates. Do you understand? Coordinates of space. So we cannot sum y things with x things or y things with z things, right? X with x, y with y, z with z. Okay, so we need to multiply these things too. So for the first equation, we have for a sum plus 3b equals 5. Okay, this is the yellow equation or green. I don't know this color is. 0a plus 0b equals 0. Right, this is cool, but unuseful. Okay, it's
Okay.
cool, but it's unuseful. But okay, 0 equals 0, right? The last one, 0a, right, plus 6b equals 2. Okay, we have 3 equations, but only 2 is useful to us. The first and the last one. Okay, so we can solve this system in a very easy mode. We can find the value of B. Do you know what is the value of B? Do you know what's the value of B?
2 divided by 6.
Yeah, 2 divided by 6. Perfect. This is 1 over 3, right?
Yeah.
You can simplify these things. So you know the value of B. And now you can get the value of A. You need just put this value of B here, okay?
Okay.
So can you do this for me? I need to go to the bathroom. Just a second, okay? When you finish this, you say me the you will say me the value. Just a second, right?
Okay.
I come back.
Okay.
Do you know the value of A?
I got the value of A as 1.
1?
Yes.
Let me see. I will do this math too. 3 times 1 over 3 equals 5. So we have 4A plus 1, because we have this simple multiplication. We can pass 1 for the other side. We will have 4. 4 over 4, 1. Okay, amazing. A is 1. B is 1 over 3. Perfect and easy. Let's remember. We have this the question. This is our question. So we transform our question in a equation, in a system of equations, right? So using these two equations, we get the values. When we have two variables, we need two equations. When we have three variables, we need three equations, and so on. Okay? Let's go to the another one. Consider the matrix. Knowing that A has eigenvector indicates the eigenvalue associated to it. Eigenvector e eigenvalue is an advanced math too, right? But it's not so complicated. I will teach to you how do eigenvalues, right?
Yeah.
So we need a matrix, this matrix, and to take the eigenvalues, I need to repeat the matrix, but in our principal diagonal, we need to put this lambdas. Lambdas is a Greek letter.
Yeah.
So now we need to do a determinant. I don't know if you know what is a determinant, but a determinant is a math involve multiply lines and rows, something like that. Okay, So let's go. First, we need to do this. To do a sorry, I need to, yeah, I'm right. We need to use the first three diagonals. Yeah, I need to repeat these two columns, right? To do this more
Yes.
easy to us, okay? So it's important we know that it needs to be equals 0, right? All the math we need to do here is equal 0 at the end. But okay, let's go. First diagonal, minus lambda times 3 minus lambda times 2 minus lambda plus the second diagonal, minus 2 times minus 1 times 3, the another 2 times 1 times 0. Right, okay, perfect. So now we need to do the another diagonals like this, this, and this, okay? This is the equation of the determinant of the eigenvalues, right? So in this situation, take the secondary diagonals. This is the name of the orange ones. We need to put a minus in the front of our counts, right? This is one thing only, but I don't have space to write here, okay? So I will write down,
Okay.
okay? So we have the first 3 times 3 minus lambda times 2 plus 0 times minus 1 times minus lambda plus 2 minus lambda times 1 minus 2. Everything equals 0, right? So we need to do these multiplications. This is very boring, but it's necessary, right? So I will do this here. Okay. First, I need to do this distributive property. Very boring, but okay. We have 6 minus 3 lambda minus 2 lambda squared. Okay. But everything is multiplied by this lambda here. Okay. Because I need to multiply this lambda yet. Let's go to the next. 2, 6. Here is 0. So let's go to this. 6 times 3, 18, minus 6 lambda. Here is 0. And here, oh my God, this is a number 2. Okay. So minus 2 here, plus 2 lambda, and here minus 4, right?
Yes.
This is the math, okay? You need to pay attention because it's a lot of things, a lot of signs, a lot of numbers. So we need to have a lot of attention too. Okay, let's continue to simplify this. Here we have minus 5. So we have lambda cubic minus 5 lambda square. But I need to change the sign. And here, minus 60. Okay. Plus 60. And here, minus 80 plus 6 lambda. Oh my God. We have minus 4 plus 4. And here we have plus 4, 2, and equals 0. So we can solve some things. No, we have here. We can group these two things. So 9 lambda square minus 6 lambda. And here, and here, we have minus 8 equals 0. So we have 3-degree equation, okay? And we need to solve this equation. But this is a 3-degree equation. It's hard to solve this, okay? Because we don't have the quadratic formula, for example, and we cannot isolate the lambda too, okay? So we need to choose some easy values to put in the equation to observe that is roots or not. For example, we can try the lambda equals 1, for example. We just will try, okay? If we put 1 in the lambda, we have minus 1 plus 9 minus 6 minus 8, okay? So we don't have a solution of this value. This is a problem. But okay, if I'm wrong in another part of this map, but you was look this with me, so I suppose I'm right. Okay. I suppose I'm right. I'm not wrong here. This is a easy math, but I never know. No? This is a little difficult. But this looks like you're right to me. This is like very right to me. Okay, this is right. This is right. I am not wrong. This is very easy. Okay, so we need to try another value. Let's go. Let's try another value. I will try the minus 1. I will try minus 1. Because if we choose the right value, we obtain a eigenvalue. This is the eigenvalue if our sum have a result 0, right? So let's try this value. 1 plus 9 plus 6 minus 8. So this is different of 0. So we need to try another values until you get our 0, right? But I really don't know. I have a question for you. Can you use calculator in your test?
Yes, I can.
Okay. This is very easy. You can put this equation in the calculator. The calculator finds the roots for you. Okay?
Okay.
I don't know if you have your calculator now, but I will do this for you in my calculator. Okay?
Because I have my calculator.
This is easy for you too. I will show to you just a second. For example, we have this site. This is a very powerful site. I will put the equation here, and it finds some solutions for you. Okay, these 3 solutions. This is the 3 eigenvalues. Okay. So using these eigenvalues, you can find the eigenvectors, but the math of the eigenvectors is a little longer, so I cannot do this for you now, okay? But it's easy if you search in the internet how you can find the eigenvectors when you have the eigenvalues. You will be easy, okay? But I can do this for you now. I will do for you another moment, okay? I will do here in my computer, and I send to you a PDF with this solution, okay? because now I have to do another class, so
Okay.
I cannot finish it to you. But I will do this in a PDF to you. Okay. So,
Okay.
okay, this was an amazing class. You are very cool, and I will send it to you all this math. Okay, I will change to you. I will send it to you in your WhatsApp. Okay, to you study what we do here. Okay, so
Okay.
thank you for our class, and bye bye.
Thank you. Bye bye.